Let me introduce myself. My name is Doug Joseph, and this is MAT 103, Intermediate Algebra. So make sure you're in the correct course. We're going to begin by going through the syllabus, and then we'll take attendance after that. So just a little bit of information here. I'm a full-time faculty member, so you can leave a voicemail on my office phone, or you can contact me at my email address there. Office hours are on the back page. That way you can see when I'm available. Course information. Again, this is Intermediate Algebra. Just make sure you have the correct textbook. Should look like that. If you don't have the textbook yet, you can pick it up when we take our break from the bookstore. Now we'll go on and talk a little bit about the basic course description and what we'll be covering. This class covers, again, just some of the basic concepts in algebra. And this course is designed to get you ready for college algebra. So that's what we do in this course. You'll need a C or better to go on to the next course. And you should have placed into this course by either taking elementary algebra or taking one of our qualifying placement exams. Learning outcomes, we're not really going to talk about those per se, but we're going to learn how to graph lines, graph a few nonlinear functions as well, inequalities and equations. But again, the main point of this course is to get you ready for college algebra, which will be the terminal math class for most of you. And then we have our major content areas. Again, we're not going to talk about these, but these are what we're going to be covering. Next page, we'll talk a little bit about how we're going to do the homework. And in this class, at the beginning of every chapter, and I'll give you this here in a moment, you're going to get a homework packet. And this homework packet has all of your homework for the entire chapter. So we're not going to cover all of this today. But this way, you can work ahead. If you're gone or you miss class, you can go ahead and complete your homework. It's just easier this way because you don't have to have your textbook and accidentally do the wrong problem. That's a commonly made mistake, is I'll assign questions out of the textbook, you'll accidentally pick the wrong question. So this way, it's all nice and neat. You can attach work at the end if you need to, but there's answer blanks for you to fill it in. The main thing about mathematics is being organized. To be successful in mathematics, you really need to be organized. And that's what we're going to try and teach you and promote, is how to be organized. A lot of times I look at students' work, and it's really hard to decipher what happened. And I want you to be more cautious of that. Try to write things where you can find your answer. And that way you won't make a mistake. The most commonly made mistakes in algebra are sign errors, or just forgetting where you were at and writing on the wrong number. So we want to make sure we don't have a lot of those. But as you can see, and I'll pass this out in a moment, all of your homework is in this packet. So at the beginning of every chapter, I'll give you the homework. I collect the homework at the end of the chapter. So when we take our exam, you'll turn in that homework packet. And then I'll get that graded for you. The reason why I don't pick it up every class period is this way, if you have questions, you can go back and you can fix them. A lot of times, you may really feel confident about your homework. You've done it all, you think, I did all these correct, come to class, we go over a few questions, and then you figure out, okay, I made some mistakes, so I can go back and fix them. Math is all about making sure that you understand the concepts. And if that means going back and reworking some questions and looking at things, that's the goal of it. Math is a little bit different from other classes. In other classes, like a history course, you need to memorize things and write essays. In this class, mathematics is more like riding a bike. Okay, it's a skill. I'm teaching you a skill. So when we take exams, we take them in class, and you can either have a page of notes or note cards to help you with that. I'm not trying to make you memorize things. What I'm trying to do is teach you the skills that you need to be successful. That's the main goal. So it is different from other classes as I'm teaching you a skill. Next, we'll talk about how I assign grades. I use the standard college grading scale. 90 or above is an A, 80 to 89 is a B, 70 to 79 is a C. Most students do very well as long as you attend class, and if you happen to miss a class, it's not the end of the world because I post the notes online along with videos for you to watch. So you can see the lecture. So if you're gone for a class period, you can log in, you can see your notes, and you can see the videos as well. So you can keep up with the course. A lot of times things happen. You may miss a class period or two. Hopefully it's not because of COVID, but if that happens, we have options for you to be successful. I do take attendance every class period. Now I don't assign attendance points like I normally would. Normally in this class I would give you points for attendance. In this class, I don't, because I don't want someone to lose points because they're ill with COVID or sick with something else. If you feel ill, stay home. You can watch the video, you can keep up with the class. We really don't want anyone else to get sick, so if there's any doubt at all and you need to miss class because of illness, don't let that hold you back. Academic honesty. I encourage you to work together on your homework. I think that's one of the best things that you can do, is work together in a small group. When we take our exams, though, that's me making sure that you understand, again, those skills. So you'll want to work together in your homework, but exams are just making sure that you understand the concepts. And we have a few more statements to go through. If you have any sort of special needs, you'll want to contact our advisor at allencc.edu. Thank you. And that advisor can work with me, and we can come up with any special accommodations that you might need. Another important statement is our email. So at Allen, you have your Allen email. You want to make sure you check your Allen email. This is how you'll get the notes from the lecture and the video links. You might also get emails from student services saying, hey, it's time to enroll for next semester. So you really want to check your Allen email a couple of times a week. If we have to cancel class because of inclement weather, I'll send you an email as soon as I know something. That way you're aware of what's happening. The next part is academic support. We have the library, we have the writing center to help with writing papers, and we do have some math tutors. Next week, hopefully, we'll have a detailed list of the times that the tutors are available. We're just still trying to get tutors for our math center, so we're looking at scheduling right now. Next week, though, I'll make sure that you get a copy of the schedule. The next part is a detailed breakdown of the course and all the points that we have. I call it the course calendar, but I don't put dates on the calendar. And the reason for that is we may have inclement weather. And so it's easier if I don't put dates on, but you can kind of follow along. As soon as we finish up 1-7, we're looking at an exam. So you can keep track of it as we progress through. These are the topics and chapters and sections that we're going to be covering and the point values associated with them. There's several pages there. It kind of broke it down into modules. The last part is my office hours. So if you ever need to get a hold of me, you can see when I'm on campus. I'm on campus Monday through Thursday. You can always send me an email if you need to on Friday or the weekends. So it's all broke down here as to when I'm available. Don't ever hesitate to reach out and contact me. If something happens and you have questions of your homework or you're going to be missing class, just let me know. I'll go ahead now and pass out our homework packet. And then we'll go through our attendance roster. You're welcome. You're welcome. You're welcome. Okay, now again, we are not going to cover this entire packet today. We'll probably only do 2, maybe 3 sections. So that's generally what we do, is we do 2 to 3 sections every class period. So now let's go ahead and go through the roster. I'm not going to pass out the roster. I'll just put it on the screen. Say your name and mark you off as being here. Okay. And just so I don't, if there's anything that I'm not sure about the name, might just ask you to say it real quick. How do we say your name? Jia Yuanchen. Okay. Yep. Trying to make it as so I can say it correctly because I don't want to butcher everyone's name here. Okay. And Perla. All right. And Tommy. Okay. And Josephina. All right. And Lance. And Eli. Okay. All right. And normally I would pass out the roster, of course, but we want to really limit contact of papers and things. So now we'll go ahead and get started. And I'm going to turn one of the bank of lights off so it's a little bit easier to see here. That makes it a little bit easier to see. And we'll go ahead and get started here. We're going to start with Chapter 1, Section 1. And while we're getting ready to take notes, I'll talk a little bit about the class structure. So we're here for a 3-hour block. What I normally do is try to lecture for about 45 minutes. We take a break, come back, do about another 45 minutes, take a break, and then we finish the class. Most class periods we start off by answering questions from the homework. But, of course, we don't have any homework yet to look at. So we're just going to begin with our first lecture. Some of this course might be review for you. It might not be. We're going to start basically from square one with a lot of things. A lot of you may know how to do these already, but you really want to be careful and break any bad habits that you might have. So we're going to go through things, make sure we understand the definitions, and how to work out your homework. So we're first going to begin with some definitions. So in this class, we do need to have some basic definitions. That way, when you see the terminology in your homework, you understand what they're wanting. And so we're going to begin with looking at the difference between an equation, and an expression. Now, an expression has no equal sign and cannot be solved. So no equal sign and cannot be solved. And let's look at some examples. 3x plus 5. That's an expression. 4x minus 7 and 2x plus 1. So that's the definition, the basic definition of the expression. When I give you definitions, I try to make them as simple as possible. Sometimes when you read the textbook, they give you a hard to understand definition. And so I try to put the definitions in my own words and something that you can actually understand. So that's an expression. So no equal sign, we can't really solve it. We might be able to combine like terms together and simplify it, but we can't find the value of x. Next, we have an equation. And an equation has an equal sign, and it can be solved for a variable. So let's look at a basic example of an equation. How about 3x plus 5 equals 9? So this is an example of an equation. Now, with equations, we can solve it. We don't really work with expressions that often in this course. We generally focus on equations. So we need to make sure that we know how to solve an equation. Now, when we solve an equation, we work in terms of opposites. And what we do first is we try to get the variable on the left. Everything else on the right, we do addition, subtraction first, divide at the end. So the first thing we're going to do is move that 5 over. That leaves us then with 3x equals now 4. Once we have that, then we can finish it. And we finish it by dividing by that 3. We leave fractions in this course, so we'll leave this as x equals now 4/3. So this again was an example of an equation. Why is it an equation? It's an equation because we have an equal sign, and we can solve this for the value of x. We can find what x equals. Now we're going to look at the 3 different types of equations. And they are contradiction, identity, and conditional. So we'll start with a conditional equation. And our definition of a conditional equation is an equation that can be solved for a variable with an answer. So you're going to get a numerical answer. So it can be solved for a numerical answer. So we're going to be able to solve these, and we're going to get an actual answer. The last one that we did was a conditional equation. And let's take a moment to think about conditional. Okay, conditional means there's a condition that makes it work. So a number that makes it work. So that's why we call it conditional. So in our last equation, that 4/3 was a solution. that was a conditional equation because we have a solution. We have a number that makes it true. So here's an example of another conditional equation. So this is an example of a conditional equation. So we want to solve this one. So when we solve a conditional equation, first thing we need to look for is parentheses. And we have some parentheses, so we're going to get rid of our parentheses. And we do that by distributing or pushing through that 3 out in front. And that leaves me then with 3x minus 12 equals 7x plus 3. So we distributed that 3 through. And now we'll begin solving it. For this question, I'm going to do all the steps. Later on, you might see me do 2 or 3 steps at the same time. And that's just because we can move things around all at once. But this particular problem, since we're just starting out, we're going to move things around 1 step at a time. Now, what's my goal? My goal is to get that x by itself. Okay, we normally want the x on the left. So I'm going to move that 12 over with addition. We work in terms of opposites. So that leaves you with 3x equals 7x, and 3 and 12 makes it 15. Is everyone okay with that so far? Now, what do we do for our next step? We move that 7x over, right? Because we want to make sure we get the x on the left. Everything else is on the right. So we move that 7x over with subtraction. And that leaves me then with a negative 4x equals 15. And that's one of the commonly made mistakes is signs. So we take that 3 minus 7. 7 is larger. It has a negative sign, so we subtract them. My answer is going to be a negative 4x then. We'll go ahead now and divide by that negative 4. And what we do with a negative is we bring it up to the top. So when we write our final answer, we're going to take this negative that's down below, and we're going to place it on the top. So my final answer will be x equals a negative 15 over 4. Now again, this is a conditional equation. And why is it a conditional equation? Because we get a numbered answer out, right? Okay, and watch your signs. Be careful with that. See how I move things around? I brought that negative up to the top. Another type of equation that you may encounter is an identity. We'll do the identity first, and then we'll talk about a contradiction. Now, in an identity, the sides are the same. And the solution is all real numbers. And you can use negative to positive infinity, but I use all real numbers because that's the way our textbook does it. But I would take also negative to positive infinity. They mean the same. How do we remember what an identity is? Well, we think about identical twins. What do we know about identical twins? Identical twins are the same, right? So when we talk about an identity, associate that with identical twins, the sides have to be the same as well. Now, they may not look the same at the very beginning, but when you manipulate things around, we'll get them to be the same. So here's an example of an identity. About 4 times x plus 5 equals 3x plus 7 plus x plus 13. Now, these don't look the same right now, but they will be here in a moment. So what do we do first? We begin by distributing that 4 through. So that is then 4x plus 20. Now what can we do? Well, on the right-hand side, we can combine like terms together. So we have a 3x and another x, so that makes it a 4x. And then what do we know about the numbers? We have a 7 and a 13. So those can go together and also make it a 20. Now notice the sides are the same. Since those are the same, this is called an identity. And the identity has the solution, all real numbers. Okay, so that's what we're going to call our answer, identity, all real numbers. We don't encounter identities very often. Mostly we encounter conditional equations. But once in a while, you may have an identity. And again, what's an identity? Identity just means the sides are the same. It's a true statement. They equal each other. One more type of equation that we're going to look at is a contradiction. And what's a contradiction? Well, a contradiction is a false statement. So we're going to be looking at a false statement. And that means it doesn't make sense. So the variables are going to disappear, and you'll get two numbers that equal each other that are not the same. Again, think about the definition of contradiction. Think about in a court of law, we have contradictory testimony. What does that mean? If I pull up a witness and I claim that witness gave contradictory testimony, what does that mean? That means they lied, right? They gave a false statement. So when we talk about a contradiction in mathematics, we use that same logic. So it's a lie. It's a false statement, something that doesn't work. So think about a contradictory testimony in a court of law, and think about a contradiction. False statement doesn't work. So here's an example of a contradiction. About 4 times x minus 7 equals 4x plus 19. And once we finish this question, then we're going to look at some more difficult equations. Once we finish this one, this is the last of the 3 types, then we'll look at some specific questions that involve maybe square brackets and how to clear out fractions. This is just understanding the 3 basic types of equations. So we begin by distributing that 4 through. And that leaves me then with 4x minus 28 equals 4x plus 19. When I move that 4x over with subtraction, that leaves you then with a minus 28 equals 19. And does minus 28 equal 19? No. We know that's a false statement, right? Minus 28 does not equal 19, so that's false. So this is a contradiction. And how do we write our answer? We use the empty or the null set. And that's just the Greek letter phi. 0 with a slash through it. And that means there's no number that will make it work. So those are the three basic types of equations. And let's just quickly remember, how do I tell if a number is a solution? Okay, now what's a solution? A solution is a number that if I plug it in, will make it work. So let's see if this is a solution. So is x equals 3 a solution to 5x equals a negative 15? Is x equals 3 going to be a solution to this? Now, how do we tell if something's a solution? Solution, when I plug it in, should make it true, should make the sides be the same. So solution is just a number that works. Well, let's check. And you can look at this one and quickly tell that it's not going to work because the left-hand side is 15, the right-hand side is a minus 15, and this is false. So what does that tell me? X equals 3 is not a solution. And again, what is a solution? A solution is a number that when you plug it in, will make it work. And x equals 3 does not work, does it? Right? These are not equal. Those do not equal each other, and that's not a solution. And the first two questions in your homework are just plugging in the numbers that are provided and seeing if it's a solution or not. And then 3 and 4 in your homework are talking about equations and expressions, which we covered. 5 through 8 are solving equations, which we're going to do more of those. And then 9, 10, and 11 are understanding if it's a conditional, contradiction, or an identity. And we're going to do more examples of the last ones, which are solving equations. So we've got our definitions down. So let's just take a moment to review our definitions. What's the difference between an equation and an expression? The equal sign, right? Okay, so we know that. That's the difference. What's a solution? Solution is a number we plug in, and it makes the sides come out to be the same. What are our three types of equations? Contradiction, meaning there is no solution. That's a false statement. Identity, think about identical twins. They are the same. It's a true statement. Solution is all real numbers. And finally, conditional, meaning we get a number that makes it work. Now we're going to start solving some more equations. And most of these are going to be conditional. We're going to focus first on a few equations that have fractions in them. So I'm going to pick a couple of problems from our textbook to look at here. Find a few good questions to work through. We're going to start with fractions. So I'm on page 65 in your textbook. We're going to look at question 59. So page 65, question 59. And if you don't have your textbook, that's not a problem at all, because I'm going to write up the question on the overhead here. And we need to make sure that we understand how fractions work. A lot of students struggle with fractions more than anything else. Decimals normally don't bother students because you can use a calculator, but fractions do. And it's just something in our nature. We see a fraction, we think it's going to be a more complicated problem. So how do we handle the fractions? We get rid of them as soon as possible. So we try to get rid of fractions at a very early stage of the question, because it just makes it more difficult if we keep them. How do we clear out the fractions? Well, we look at the least common denominator, the LCD. And the least common denominator of 2 and 3 is going to be 6. Now, why is that 6? Well, does 6 divide by 2 evenly? Yes. Does 6 divide by 3 evenly? Yes, and 2, right? 6 divided by 2 is 3. 6 divided by 3 is 2. So we're going to use a 6 to clear out all of our fractions. So we're going to put the 6 out in front, and we're going to distribute it through. Has to go through every single part. When we distribute through and clear these fractions, what we're going to be doing is dividing by the number down below, multiplying by the number on the top. Now, down below is called the denominator. The top half of the fraction is the numerator. So the denominator in this case would be a 2. So 6 divided by 2 is 3, right? Times x, that makes it a 3x. Next one, 6 divided by 3 is 2 times x, that makes it a 2x. And then don't forget the right-hand side. 6 times 5 is a 30. Does everyone all right with that so far? So all the fractions are gone. Now what do? These can go together as a 5x equals 30. And how do we finish it? Divide by 5 and reduce. So what is our answer? X equals now what? When we divide, sorry about that, x equals now 6, doesn't it? So that's going to be our answer, x equaling 6 here. What type of equation is this? Well, we got an answer, so this would be conditional. So we cleared out our fraction, or our fractions. We divided and we got our final result there. This was conditional. That was a simpler one with fractions. Now we're going to progress and get some more difficult ones. So question 64. We're going to focus a lot of our time today on fractions in 1-1 because that's where students struggle the most. Then we'll look at a couple that have square brackets. Mostly, we're going to focus on fractions. So question 64. And question 64 is 5 minus x over 6 plus 5 over 6 equals x over 54. Now, there are a couple of ways of working this question out. You could combine those together. Why? Because they're both over that denominator 6. But I'm going to go ahead and get rid of the fractions first. I think it'll be easier if we just get rid of the fractions at the very, very beginning. So we have this. Now this is 2 fractions, so I'm going to split it up into 2 separate parts and clear the fractions. So rewriting, that would now be 5 over 6 minus x over 6 plus 5 over 6 equals x over 54. A lot of times, too, you'll see me divide my paper, and this will be my work on the right-hand side. The problem will actually be on the left. Now, the least common denominator of 6 and 54 would be 54. And why is that? Well, 54. Does 54 divide evenly by 6? Yes, because 54 divided by 6 is what? 9, right? 9 times 6 is 54. And 54 divides evenly by itself one time. So we're going to clear our fractions by multiplying everything by a 54. Now again, an alternative way would be combine fractions together and cross multiply. You can do that too. There's all kinds of different ways to work out and solve these questions. I try to show the easiest way, the one that I think is the least confusing. We're going to now distribute that 54 through. And how does this work? What are we going to do? We're going to divide by the number down below, multiply by the number on the top. So 54 divided by 6. What's 54 divided by 6? Okay, 54 divided by 6 is 9, right? Okay, 9 times 5 makes it a 45. Next, 54 divided by 6. 9 times a negative x, that makes it a minus 9x. Is everyone okay with that so far? Divide by the number down below, multiply by the number on the top. 54 divided by 6. What's that again? 9. 9 times 5 is a 45. On the right-hand side, what do we have? 54 divided by 54, well, that is a 1. So that's going to make it a single x. So we have now successfully cleared all the fractions. So now it's easy. We should know what to do. I'm going to begin, before I move things across the equal bar, I'm going to begin by combining. So 45 and 45, those can go together and make it a 90. Now what can we do? Well, it doesn't matter if we get the x on the left or the right side. Normally we keep it on the left, but in this case, we can move that 9 over with addition. So that 9x can be moved over. And now we have 90 equals 10x. We'll divide by our 10 on both sides. And that now leaves me with x equaling 90 divided by 10 is a 9. And when we write our answer, we write our x on the left. So there would be our answer, x equals 9. And this again is conditional. And we cleared our fractions. Let's look at one more of these. Then we'll look at some square brackets. And then we'll take a short break. So let's look at one more. Question 68. We're just slowly increasing the difficulty. And so question 68 here. (2x plus 5 over 5) equals 3x plus 1 over 2 plus a minus x plus 8 over 16. Well, what do we want to do? We want to get individual fractions. That way we don't make a mistake. So before you do anything else, make sure you have all individual fractions. Break it up into individual parts. So we're going to take this 2x plus 5 over 5, and we're going to break it down into the two fractions. And we can reduce these down, but I'm just going to leave them as they are. And we'll clear them out by multiplying. You can reduce them down if you want to. I usually just write them as they are. So we have 2x over 5 plus 5 over 5. Now again, that 5 over 5, that could be written as a 1. Doesn't matter. I'm just going to leave it as a 5 over 5. What about the next two pieces? We've got that 3x over 2, and that 1 over 2. So that's going to make it then 3x over 2 plus 1 over 2. And now we need our last two, which are here. So we're now left with a minus x over 16 plus 8 over 16. And we could break them down and we could combine them together. I generally don't do that because students struggle with fractions, and the best thing to do is get rid of the fractions at the very, very beginning. That way we don't make a mistake. Fractions just, they look more difficult. They're not. We're going to get rid of them at the very beginning. So what would I use for my least common denominator? Well, let's break it up and see. Okay, the least common denominator of 2 and 5 would be what? Does anyone know? 10. Okay. And we're going to break this up into two pieces at a time. So the least common denominator of 2 and 5 is 10. What's the least common denominator of 10 and 16? Well, the least common denominator of 10 and 16 would be what? Not 16, not 160, it would be 80, right? You could use 160, but 80 is smaller. Does 80 go into 2? Yes. Does 80 go into 5? Yes. Does 80 go into 16 as well? Yes. Because it goes into 16 5 times. So now what are we going to do? We're going to multiply everything by an 80. That's going to clear out all of our fractions. And what's our rule? Divide, multiply. Divide by the number down below, multiply by the number on the top. So, 80 divided by 5. Well, 80 divided by 5 is 16. And 16 times 2 makes it a 32x. 80 divided by 5 is 16. Times 5 makes it an 80. So that comes out. You could have also reduced that down to a 1. 1 times 80 would be the same. Next, 80 divided by 2. Well, 80 divided by 2 is 40. And 40 times 3 is 120x. Next, 80 divided by 2 is a 40. Times 1 makes it a 40. Next, 80 divided by 16 is a 5. Times a negative x makes it a minus 5x. 80 divided by 16 is 5. 5 times 8 makes it 40. Is everyone okay with that so far? Let's see what we're doing there. Now, what are we going to do? Well, we're going to begin by combining like terms together. The left-hand side is already done, so let's work on the right-hand side. Well, if I work on the right-hand side, I get 120 and a minus 5x. That makes it 115x. 40 and 40 makes it an 80. And that equals then 32x plus 80. Now we're going to go ahead, combine like terms, and solve this out. So I'm going to move that 80 over with subtraction. And that leaves you then with 32x equals 115x. A lot of times students make a mistake here. We want to go ahead and get this to have the x's all on the left-hand side. So what are we going to do? We're going to go ahead and move that over. So we're going to move that 115 over. Watch your signs. When I move that over, that should make it then minus 73x, right? Sure did the math right here. I think I did. So minus 73x there. And what are we going to do next? We're going to have to divide by what? Negative 73. And what is any number divided by 0? Well, any number divided by 0 is 0. So what's our answer going to be? X equals now what? 0. I picked this problem because students make a mistake here in this part. When we move things over, we replace it. It's all gone. We replace it with a what? 0, right? 0 absorbs other numbers. So 0 divided by any number is just itself being 0. Let's do one more, and then we'll take a short break. So let's look now at one question that involves square brackets. And let's look at question 50. This is on page 64. Question 50. And we'll take a break after this question. Yep, still in 1.1. I wanted to try and finish up 1.1 before we took our break. Now I picked this one because it has square brackets, and our answer should end up being an identity. Why do we use square brackets? Well, we use square brackets because we already have parentheses. And we don't want a lot of parentheses together because then we get confused as to what is what. Now, when we have parentheses and square brackets, what we do is we work on the inside and we work our way out. So we'll do our parentheses first, then we'll do our square brackets. So I'm going to begin by distributing this negative through here, and also this 2 through on the right. When I distribute a negative through, what does that do? All that negative is going to do is switch our signs. Okay, so I'm going to rewrite this again as 4, square bracket stays there, 6. Now distributor push through that negative, so that's going to make it a minus 1, minus 2x here, then plus 10x, and that equals, distributing that 2 through, 20 minus 3x plus 8x. Make sure you take your time and write everything down correctly here. It's very easy to make a mistake. We don't want to do that. Now, what can we do? Well, we can combine together inside of our square bracket. So I can rewrite this. Inside is a 4 out in front still. We have a minus 2x and 6 minus 1. 6 minus 1 makes it a 5. And then we still have the 10x on the end. The right-hand side, I can combine these together, and that's going to make that a 2x plus 20 on the right. Almost finished. One more step. So distribute that 4 through. Wait, did I make a mistake with the signs here? Let's make sure I didn't copy something down wrong here. Okay, distributing through. Yep, let's Let's see, does everything look right? I think it does, doesn't it? Yep. Everything looks right. Yep, because we'll get rid of that 10x here in a minute with it. So we want to go ahead and distribute that 4 through. Always make sure you are very careful. Copy the problem down correctly. That way you don't make a mistake there. So distributing through, that's a minus 8x plus 20 plus 10x equals 2x plus 20. These can go together on the right, or sorry, on the left-hand side. That's going to make that then 2x plus 20. And that equals 2x plus 20. Now, what do we notice about this one? Well, this is not conditional anymore, is it? Why is this an identity? Both sides are the same, aren't they? Right? So these are the same again. So this would be an identity. And what's our solution for the identity? All real numbers, correct. So there's your solution set there. We're going to go ahead now and take a short, about 15-minute break. We'll come back and start the lecture from there. So let's take a short break. And let's meet back at, let's say, 9:45. That'll give you a little bit longer break. Because I know we went over about 45 minutes. So I want to make sure we have enough time to get up and use the restroom if we need to. Come back and work some more questions out. So go ahead and take a short break, and I'll see everyone about 9:45.